The next talk is IAM Role Chaos, Pitfalls of Creating Identity and Access Management in the Cloud by Marion. Marion has been working as a software developer and lead consultant for Thoughtworks Germany for more than 4 years now. Over the last 30 years, she has worked with various technologies and systems as software developer, business analyst, architect, and technical lead. Marion values teamwork, improving software delivery capabilities, and delivering business values. She has a passionate interest in distributing software architectures in the cloud and infrastructure as code. Over to Marion with the talk.
Right, just a sec. I'm going to share my screen. So, I trust you can see my screen.
Yes, Marion, we can. Yeah, now we can.
No, okay, great, thanks. Yeah, thank you. Thanks, Swati, for the introduction. The pitfalls of setting up identity and access management with a slightly provocative header, the IAM role chaos. You may ask, why chaos? Well, IAM is complex and it is really challenging to set up. And if you start just right away without having any strategy on that one, you may run into a mess which is hard to maintain and hard to refactor. And you may have lost complete control who can access what in your systems or in the cloud and so on. So we may all know the question, which role is needed to access X, Y, Z, right? That sounds familiar. So you may ask, so do I really need it if it's so complex and so challenging? Well, I think Sriram already answered a lot of questions why identity and access management is really needed. So before I dive in all these challenges, we still will look into why it is important, why we really need identity and access management in the cloud, followed by what can I do with that? So which are the security principles I can enforce with that? I won't provide a universal solution because it always depends on your requirements and organization and security rules you want to implement. And I also won't provide a solution for automating the generation process of roles and policy, which would really ease our all lives. So I may leave you a little bit disappointed. Also a word or a kind of disclaimer, I will mainly refer to AWS as a cloud provider. However, a lot of measures I will talk about will also apply to all other cloud vendors like Microsoft Azure or Google Cloud and so on. So why is identity and access management important? First of all, take a step back. Traditional perimeters-based models which assume that you could establish a strong security perimeter around your on-premise network and that you can then trust all the activities within that perimeters are safe, that does not work for the cloud anymore. The reason for this is because the cloud is highly connected to the outer world and people can access your services and endpoints, storages from everywhere, and they can use their own devices for this. Now, when you move to the cloud, as said, might it be Google, Microsoft Azure, Alibaba, and so AWS and so on, then these providers, of course, are responsible for the security of the underlying infrastructure resources, such as computer, networking. So they are responsible actually for the data center. However, there is, and AWS comes with a kind of shared responsibility model, and all cloud providers have a similar concept of shared responsibility. So as said, the cloud providers are responsible for the infrastructure resources across multiple regions they are serving. So that means storages, database, networking, compute, and hardware. But you are actually responsible for what is happening in the cloud. So that means, and this is just a collection of some of the activities you have to do. You are responsible for firewall, networking configuration, load balancing. You are responsible for your data. You need to do encryption. That is your responsibility. And of course, you have to secure your applications, the operation systems your applications are running on. You need to provide proper authentication. And last but not least, you're responsible for identity and access management. And that is the little topic we want to talk about, or we want to look deeper into this. Now, what makes identity and access management so important? The tricky part already when it starts with the identity, which was proved by an authentication, but you never know how that individual obtained that key. And we heard in Sriram talk a lot about attacks and how you can inject systems and so on. And we know all the little really easy story about how keys get accidentally committed and pushed to a source control. And I tell you, there are really a lot of people just waiting for that incident, and then they can hijack the key, get access into your virtual private cloud or virtual private network, and can do whatever they do if that access key permits them to do everything. The same applies to all the endpoints you expose to the outer world. Also there you can, attacks can come into, like through an email or an endpoint storage. And through these cloud events, you do not even know what they may even contain. So they can also trigger some things inside your cloud, which you can't really think about at first. And we all remember, maybe, or you hopefully remember what Sriram said, there are systems which receive on minimum 8 attacks per week. So it's really quite likely that that can happen. And as said, the cloud is really highly connected to the outer world. You cannot really trust anymore who is coming in. So therefore, it is quite vulnerable. And what happens when somebody really manages to get into your system, it may completely blow up. Again, think about somebody hijacked a key, comes in, and with that key, this person or individual would have complete access to every single resources in your virtual private network. They could pull down each and every VM or a cluster, a Kubernetes cluster, and so forth. Of course, that is really a worst case scenario, but I think you always have to keep that in mind, that this can happen. And this is the part where identity and access management comes into the game. But what does identity and access management really means? So identity and access management actually makes sure that the right individual or identity can access the right resources for the right time and for the right reason. And identity and access management also helps you to limit the damage a security threat can cause when it comes in. So that sounds quite simple. So how does it work? So actually, identity and access management consists of two parts, or has two concepts. One is the authentication. This is where individuals or systems have to authenticate in order to prove their identity. And the second part is the authorization, which is the process of checking what access to resources an entity has or should have. So that is what then controls really the access rights. And the goal should be to limit these access rights as much as possible. Which leads us to the security principles you can enforce with identity and access management. The most prominent one, or the most common one, is certainly the privilege of the security principle of least privilege. So this should ensure that a user, or it could be also a computing process, an account has only that minimal right to access a resource that they absolutely need. So do I really need to access, for instance, in a database, all the records, or do I really need to be able to delete an entire table? Certainly not. So least privilege means, for instance, in this case, for example, to limit the access to read only and maybe only to a specific to specific columns. And that another really important security principle, and that has been also mentioned in the previous talk, is the separation of duties. And indeed, it is really related to a business operation rather than to a task. So a good example is also in cloud key management services. This could be an action such as using a key to access and decrypt data which a user should not normally have access to. So you should split both things away. One thing is maintaining a key and the other is using a key. And the separation of privilege is kind of complementing the least privilege. And this means a broad separation of users and processes. And this is indeed task. So we want to avoid that there is a super admin who just can log in or authenticate and then has access to each and every single resources in your system or in your cloud environment. Instead of that, we would like to rather separate. We would like to have, for instance, an administrator who may create a user or a role, but can't do anything else. And then there is a user who has that role and may then access a specific resource. Now, after talking a lot about theories, excuse me, now let's get started. It is easy to start in the cloud, right? Regardless whether you want to migrate to the cloud or just start on a green field. It is easy to kick off, and it's quite fast, right?
Hey, Marion, if you can hear me, we can't hear you.
Sorry? Sorry? Can you hear me?
Yeah. We can hear you, Marion.
Oh, I'm sorry. Apologies. It is easy to start. You just can create an account. You can even have a trial license. You can try things out. You can do a POC. And that is what we often see. You typically start with a test account as a kind of sandbox. And at the beginning, especially in a POC phase, you may do a lot of things manually. You may even provide access for some of the users with no or literally no restriction. However, what we also see sometimes is that this initial start becomes easily a default. So meaning there was no step back and thinking about, okay, how do I want to start? How do I ensure securing access to data? How do I want to organize my account? And how do I steer and maintain access to an account? And also, as mentioned before, manual tasks are done quite often. So you do not even have control. Okay, when did I do this one? When did I give access to somebody? What kind of access somebody has? And if these kind of accounts are growing, or even more accounts get created, or when speaking in Azure language, more subscription getting created, with having users inside who have full access, you really lose control over who can access which kind of data. And that is not only a security problem, but it becomes also a compliance problem. Just think about that you have sensitive data to which not everybody should have access to. Now, all these measures presented here seem to be sound quite simple, right? But I just want to, therefore, I want to emphasize that setting the stage before you start is really fundamental. Of course, you should not really try to reinvent the world or try to secure the world or the universe. Always think about start small and reiterate. Moving to the cloud is an iterative process. You won't start with a full-blown thing. Typically, and that is a good practice, you start maybe only with one business unit and with one developer team, and then you create a kind of template which you can then use and adapt to roll out for other teams and other accounts or subscriptions and so forth. So as said, it's an iterative process. And I really strongly recommend to involve all stakeholders before you start. And that includes also security people. I just learned in the previous talk that there's sometimes a kind of neglected team, but that is really important. Same for applies to the business people and developer teams. So it's not only setting up security and later on identity and access management in the cloud. It's not a pure technical problem. Before you really start, you need to understand, okay, what do I want to secure and what are the policies I have to follow? So that's why it's really important to involve all stakeholders, understand their requirements, and for instance, when it comes to data protection. As an example, if you have sensitive data which require rigorous compliance with regard to, for instance, GDPR, you want to limit the access and deployment to specific regions in the cloud. You even need to specific environments that are, or maybe you need specific environments that are PCI compliant. So these are the things you have to understand before you really start. Another thing I strongly recommend is maybe not at the very first stage, but you should consider that is threat modeling at an early stage, which can be repeated over the time again and again. The next part is define your use cases and security rules. These can be quite simple rules at the very beginning. You don't, as I said, you don't have to start with a full-blown security rule set, but there are fundamentals you want to follow. As an example, all storages have to be encrypted, or all the data has to be encrypted. It's a security rule. Or no public access to a storage should be possible at all. And users should, users who access the cloud should, so your developer teams, infrastructure, security teams should only be able to access anything by using multi-factor authentication. And then next step, define your organization structure and segmentation. How do you want to start? Do you want to start, do you want to segment your organization by business units in the future? Who needs accounts? Do I need multiple accounts? And then you need also to consider to segment with regard to different environments. Of course, you should not have a shared environment of development environment and production environment or test environment. Last but not least, after you defined all your security rules you want to implement at the first stage, you need to define guardrails for access and activities. So what do I want to allow my teams to do in the cloud, and what do I want to restrict, and how do I want to restrict that? So you need to come up with some default roles and permissions. This could be as simple an administrator role, a developer role, and an auditor per account or per user group. Now, after having all these things in mind, and everybody has well understood that, you should not stop, of course. This is, as I said at the beginning, an iterative process. So you will always revisit your security rules and also your policies, and look where you have to adjust or have to extend something. And the next part is then setting up the baseline for the organization. I put some very important steps here, but of course there's a lot of more things you need to do. But the top first thing is use federation for your organization. Part of identity and access management is authentication, and it is really a good practice to use federation in your organization and implement single sign-on. So no user should be able to directly log into the cloud provider console, but use SSO and assume a role. And it's, for instance, in AWS, you can integrate all kinds of providers like Okta, OneLogin, Microsoft Active Directory, and you, in this case, if you integrate these identity providers, you do not even create an IAM user in AWS, but the user resides in your identity provider, and you only define a specific role which has to be then assigned to a user coming in according to the group a user belongs to, and you can assign this role to this user. And not less important, of course, is to enforce multi-factor authentication. Think about this stolen key. It's, in this case, you would need two things in order to get into the system. And instead of assigning a single role to a single user, you should introduce groups which are, for example, in alignment to your team structure, and assign the required default roles to that group. So don't start to make the mistake of assigning one role to a user, and then this user needs another permission, and you need to assign yet another permission to that role. This is the point where it can become easily a mess. All these kind of roles should be assumable by the user across an account. And what does it mean? So if I log in through my SSO solution, I enter into the system, I have a role, let's say in a developer role, and this role I can assume, and maybe I want to, at the next step, because I need to do another activity, I want to assume, for instance, an administrator role. Of course, sounds also simple, never use a root account. Lock it away, and then never reopen it. You can create in almost each cloud provider solution a user or a role which has respective permission in order to administrate the rest of the account. So it's really dangerous to use the root account. Again, there are people outside who are just waiting for this, and if they can attack this account or get access to this root access, you are really lost. Implement security rules. That is last but not least. For instance, in AWS, you have AWS config, where you can implement rules, as mentioned before, like storages have to be encrypted. You can even write a rule to enforce multi-factor authentication, and or that or that all storages should be at first private and not public, so like an S3 bucket or something like that. And again, for setting all this up, you should always use infrastructure as code. Never do something manually. Use infrastructure as code and automate everything. So no step should be really done manually. You won't be, first of all, it is not scalable and you really get lost. And of course, also important is source control. You want to reproduce, you want to review what you have done so far and may adjust where applicable. All security is great if you do not do logging and monitoring. So you can introduce something like compliance monitoring, where you can see all the activities going on in the cloud and which activities may be against your compliance. And of course, you need also alerting. And all tools provide logging capabilities. In AWS, it is CloudTrail, and you can switch it on in every region you want to run your services in. Another good tool is Guard Duty, which alarms you if there is some special activity in your account. That can start like, oh, we see some access to the system, to the cloud with an IP address we never have seen before. This happened, for instance, for me. I was once working from home, and I used apparently an IP address which was at that time unknown to our VPC, and I received the email on my own and all my teammates as well, and then I could confirm, hey, it was me who accessed the system. So again, all security rules and all setup is a waste if you do not do respective monitoring and logging as well. Now, you have set up the baseline, and you will also want to, of course, onboard teams, and autonomy of teams is really important. And how do you do that? And there's a common question which we see quite often, which is how do I give the people the freedom to do things they need to do without losing complete control? So the question is sometimes, do I do a centralized or a lean preventing control when it comes especially to identity and access management? So if you do it centralized, it can happen that you become easily a bottleneck. So for each and every change you need to do, a team needs to do, it comes to you and ask you to create a new role or a new policy. Of course, in general, they will ask you then to create a respective ticket, which will then go directly to their dashboard for their activities. Another solution could be, okay, I give them the freedom at least to define the rules. So we have maybe a centralized repository where people can create pull requests, which include new roles and policies they need to create. But that may also not really scale because you are still the bottleneck, and that can really slow down not only your own team maybe as an in-platform team or infrastructure team or security team, but it may also slow down the developer teams. And it really truly limits the capabilities of developers for automation. Why is that so? Now, in AWS, for instance, you are even forced to apply special roles and policies to specific resources. You cannot even do anything without doing that. So, so it's a kind of circle. That's why delegating should be definitely be considered when it comes to identity and access management, because it enables the team to do what they need to do with IAM and let the developer teams move on quickly. Now, Of course, your main concern will be still how to delegate IAM to developer teams without losing controls. And in AWS, there are some tools, or rather measures at hand, which helps you to delegate this safely. There is the concept of permission boundaries, for example, and that ensures that a user or a role cannot grant permissions in an identity-based policy beyond that given boundary. So if you say, okay, I do not allow that a user can create or have access to a specific group of people, and if that user now tries to create an IAM role and try to assign that to this group of people, that won't work. However, the permission boundaries limits the access. They do not grant access. So you still need to define identity-based policies, in this case, to control creation of resources, but which you want to grant to an identity. And another good measure in AWS is our service control policies. And these policies define the maximum permission across an organization for a member in that organization. So organization is a term also from AWS, which is actually you can create on top of your, for your organization, and beyond this organization, you can create your organization units, which in turn then have a reference to an account. So if you create SCPs, so service control policies, they can be inherited in that hierarchy and get applied then to all the members in this hierarchy. One example for a service control policy is given here. So this denies the permission to create and delete IAM users, and for instance, to stop CloudTrail. It's really a quite simple example. And if you go back again, if I just quickly go back again, so what are the resulting permissions for a role, or for a role, or for a user, or for an identity? This is actually the intersection of all these policies. So where you have the legal check, this is what at the end a developer or a user can do when you apply with permission boundary, service control policies, and identity-based policies. As said, this is an example of a service control policy. You can, of course, it's really a dummy example. You certainly can, these in general look more complex. But again, all the security measures are useless if you do not monitor your system, and you can even automate the notifications for this. So again, I just want to emphasize at that point, use things like cloud audit logs in order to see what's happening and going on in your account. Now, by maintaining the IAM in teams, if you delegate some parts to them, is also a quite challenging thing. Nevertheless, that does not only apply to developer teams, but also to the cloud and tools team, platform team, or infrastructure team, however you call it. The first thing which becomes apparent is the sheer mess every IAM tool comes with, regardless of the cloud provider. And granular access control comes at a certain cost, and the cloud providers have comprehensive IAM tools that allows you to protect every single service and resource. I heard that AWS IAM comes with roughly 4,000 action and counting. So again, this is and I think it's really growing. So you have to deal with a lot of things. Of course, you don't have to keep everything in mind. There's good documentation, and you can look up each and every single action you can perform on a specific resource. Nevertheless, don't underestimate the mess. Also, the policy structure and language, in quotes, is sometimes a little bit strange. You can deny, you can allow, there are not actions and actions, and it's sometimes quite confusing. Therefore, there is a certain learning curve to get into that one. And to give you an idea about possible actions you can perform and which you can then define in resources or as an allow or deny, this is a simple example for lambda actions. And this is a really quite short list in comparison, for instance, to a good old EC2 instance, where you have tons of actions you can apply or define in a policy to allow or disallow. And the granularity here comes in where you can say, okay, I only add permissions for deploying a lambda function or for updating the function code, but for all the other things, I don't apply a policy for deleting the function. Now, if you go the path with delegating, there will be a certain freedom for the teams. And as mentioned before, it is a mess and there is a learning curve, which every team has to go through. And the pitfalls for here are really first of all, capabilities of the team. Not everybody is familiar with identity and access management, with the specific language and how it is really working. I can just remember myself when I started, I think 5 years ago with identity and access management. I was really also really overwhelmed by all these kind of things, which I can do with that. So it's a learning curve. Then the other pitfall is that least privilege is really challenging to set up. It's a journey. Because it's really tedious to set it up. And sometimes you ask yourself, if you didn't do that, why in the hell I still cannot access what I want to do with that? Or why can't my resource access what I want to do? Time constraints. Sometimes it appears in teams, hey, you have to get done with that X, Y, Z. And there is sometimes a tendency to overrule least privilege by time constraints, which is really a risk. Last but not least, and I will come to this in a bit as well, cicd tools, or in particular the deployment pipeline, can lead to some pitfalls. As I said, I will come to that a bit. And of course, there's the human factor. So I always also sometimes ask myself, well, can I just put in this little wildcard there in order to get done with that? And no, it's not there. Yes. And I can say, no, just don't even dare to do that. Because every single wildcard can create a mess you will really regret. It is really hard to refactor, and the refactoring may take even longer than setting up least privilege at the beginning. Least privilege, as mentioned, is a journey, and getting there is an iterative process with a lot of testing and repeat, but it is worth to go through that in order to secure your systems properly. Now, here are some measures you can do and should do when setting up identity and access management roles and policies. A quite simple one is visualize your resources and required permissions. So look at what do I need to protect. It sounds simple, but it's also helpful for all other team members who come into your team later to see what is going on, which systems are there, how they are protected, why, what was the requirement. Again, infrastructure as code, so it should be mandatory, and version control as well. 4I principles, in this case, is good. Do pairing sessions when creating policies, so that you can really detect from the very beginning where you may go on the wrong path. Agree on naming conventions. Again, think about your team members. They need to understand from the naming of the role or the policy what it is actually doing. Also, you can put some description there. That would be also helpful for all team members coming after you. Both AWS and GCP, Google Cloud Provider, provide a similar policy simulator tool. They are really quite powerful, or at least I'm quite familiar with the AWS one. You can really simulate new policies, or you can even check why a policy is currently not working, which is already in the system, and then you can try out what is wrong with that policy. And regular reviews of your roles and policies should be also mandatory. Maybe sometimes you do not even need them anymore. Last but not least, coming to the cicd tool. Least privilege for the mighty cicd tool is a challenging thing as well. In order to deploy the infrastructure code for the services and application, this tool needs permission to do so, right? And so it requires permission to destroy, create, update resources in your VPC. So what next? And over the sudden, of course, you think, oh my gosh, this would require more or less God permission in the context of infrastructure. And here's an almost real example about that one. I can tell you it's gone, but these kind of things are really happening in reality. So what can you see here? In this case, this policy for a specific role that deploys to something allows all actions on EC2, load balancing and auto-scaling. And all the listed actions on the right-hand side are allowed for all kinds of resources. I do not want to make jokes about this. These are things which can happen if you start without thinking and about a strategy. And I can also tell you what happens here. I mean, the system was growing, the infrastructure was growing, and then you think, oh, hell, I need to apply yet another policy so that my deployment can go through the pipeline. In this case, as I said, that has been also mitigated. Refactoring this policy took really a long time. Fortunately, there was an SCP, so a service control policy in place that took care and limited the permissions for that particular team account. Now, here are some measures you may undertake in order to make also your pipeline, your infrastructure pipeline and your respective tool more safe. First of all, before you start, consider not all steps need the full permission for deployment. The build step may require access to your container registry. But think when you start implementing your pipeline and think about policies and roles you want to apply, think again about least privilege and separation of duties. Again, you don't need the full-blown access for that particular role that is running the pipeline. Define a deployment role per service and function. Sounds really that it is a lot of effort. Yes, it is, but it is worth to do so. Having a CI/CD role that can assume these deployment roles, and then you think, okay, what is the difference? It can assume the role. Why can't it just have simply directly this policy? There's a trick you can do, for instance, deny permission for listing all roles. So if somebody ever has managed to get into and hack this CI/CD role, they still do not know which role to assume in order to get further. And then, if possible, consider using tags. So some CI/CD tools come with tagging, where you can use specific agents for specific tasks. And you can also apply these tags then to your policies. So this is a quite simple view on a pipeline. You see a build, test, security, scan, deployment to dev, and deployment to prod step. So what happens on a commit and push, the pipeline will start. And here it's quite simplified. You can see, okay, the development step then can assume a role that does a deployment for a specific resource. Might it be a lambda function or something, or even a managed DB or a message system. And the same then applies to the production deployment. Again, here's a separation of duties. We have different roles for deployment to dev and deployment to prod, and also the least privilege. And here's a simple example for deployment role and policy. So this is what I meant. First, define a deployment policy for the resource you want to deploy. In this case, it is a lambda function, and you have a lambda role that with a policy that allows to deploy. I also put a little image from the policy simulator here, and you can see here is the my lambda role with that given policy. And if I just try to update, for instance, a lambda function with that particular resource of this particular resource, the permission went through. And then, of course, you need a policy to allow assume deployment role. So you, in this case, you allow the CI/CD role to assume the deployment role. And you can see if I assume that role, again, in the policy simulator, this security rule, this security simulation went through. But you can also see that, for instance, that a direct change of the AWS Lambda function by the CI/CD role is denied in this case. And then you need also to attach an assume update role policy to the CI/CD role that is shown here again. I just went a little bit through. I see that we are already running a little bit out of time. And last but not least, you need also on the lambda side, you need to allow to assume the deployment role. Right. After a more deep dive now in policies and roles, I like to wrap it up. First of all, IAM is fundamental to limit a damage in case of security threats. And setting up IAM in the cloud is a journey, so never underestimate it. But don't take it or don't treat IAM as a neglected child. Involve teams like security teams, business teams, and all kinds of other stakeholders in order to understand what do I want to secure and how I want to secure and why. Do not start right away. Setting up the baseline at an early stage is an important step. Otherwise, you will certainly run into a mess. Least privilege over time constraints. Never ever do that. Even though it takes maybe a day longer, the investment is worth to do. Otherwise, refactoring will even take you more time at a later stage. Delegating over preventing. I'm a strong advocate for that. Maybe also a little bit opinionated on that, but I think in order to balance security concerns and team's freedom, you have good tools at hand in order to limit the access rights for teams and give them, on the other hand side, freedom. That's it. Thank you. So I stopped sharing unless somebody has a question for that for a specific slide. Otherwise, I stop sharing.
Thank you, Marion, for such an insightful talk. We do have a couple of questions in the Q&A. Can you just once? Just check the open section.
Yeah. Just a second. I just try to find the window. Okay, why one pipeline per service? Can I have generic pipeline where and pick a component for a bunch of microservices I have in my project? Yes, of course. I mean, you can have a generic pipeline, which then, which can be used as a template. I would recommend to have per service a pipeline in order to because of also of security concerns, so that you can really separate. So if something is going wrong, if you deploy one service and another service, that you have then particular roles which can do the deployment, and that may impact the security. It depends a little bit on what the services are doing, actually. But typically, I never saw that I deploy multiple microservices with one pipeline, to be honest, based on my experience. What are some best practices to manage access to AWS resources? Any links, direction would be helpful. I think, to be honest, that might be a little disappointing answer, but AWS has a quite comprehensive documentation where they also provide some architecture best practices, especially also for identity and access management. I really would strongly recommend. It takes a time for reading, but I would definitely do so. I hope this answers a little bit the question. Are IAM users defined on per region basis? No, you would do. So in general, you would you have an account, for instance, in AWS, right? And an account may act across regions. So if you say, okay, so I'm sitting currently in Europe, so I'm talking about Europe. So you can say, okay, I want to have the EU West Central, which I want to serve, and I create the user for that account only. It's unrelated to the region, and the same applies for the entire IAM system. It's a global setting. It's not a regional setting. So, any questions?
That is all, Marion. You answered all the questions. Thank you.
Okay, good. So thank you.
There's one more.
It just popped in. Now I have to switch. Similar features like what? So yes, of course. I mean, as I said, I referred mostly to AWS because I'm mainly familiar with AWS, but GCP has a similar feature. So when I talk in AWS about accounts, you have in GCP, you have projects, and you can also organize the projects in the same way. And you have also a very comprehensive identity and access management tool and services in GCP. And the same applies to Microsoft Azure. However, I would say AWS has really it's really from the mess or from the data or from the number of policies you can apply is certainly the most powerful one. And they have a little, as I said, they have a little different concept. For instance, in AWS, you have to you are forced to apply policies, whereas, for instance, in Azure, you don't have to. So there are a little some differences, but as I said, the steps you have to undertake to plan for it are, I think, for all providers the same. You have to understand what are your requirements when it comes to security and policies. Okay. Any other question coming in last minute?
Thank you, Marion. Thank you so much.